Hello, we are working on binomial probability experiments, and we're going to look at how to calculate the probabilities using the binomial distribution function in Geogebra. Example 4.10 from class says a fair coin is tossed 10 times. We want to calculate the probability of getting exactly 3 tails. There's another video in my feed that shows the calculation of this outcome or this probability distribution by hand using the hand calculation. We're not worried about that today. What we want to do is look at how the GeoGebra functions will work. So in GeoGebra, we're going to type in the binomial dist, which is the distribution, and we're going to type it in exactly as we see it. So really quickly, what is a binomial probability? A binomial probability is when we have only 2 outcomes, either success or failure. We have a fixed number of attempts. In this case, we have 10 tosses, so the number of attempts is 10. We have the probability of success, which we are defining as a tail of 0.5, and in this case we want exactly 3, so we're going to let x equal 3. So there are 2 different ways of doing this in GeoGebra. The first way is to use the binomial distribution for exact calculations with the curly brackets. And the second way is to use the cumulative distribution by entering either true or false after our entries. I'll show both of them. So first thing we're going to do is start typing forgot the whole first word, binomial. I'm not a huge fan of using the drop downs. It gets a little bit confusing. There's a bunch of different options here. I'd rather just type it in exactly as I want to type it in. So binomial dist, open parentheses. And the first thing we need to enter is the number of trials. In this case, we have 10 trials. Second thing we need to enter is the probability of success, 0.5. And then the third thing that we need to enter is the number of outcomes we are looking for. In this case, we're looking for exactly 3 tails. Press enter, and we get our solution of 0.1172. We always want to round these to 4 place values. The 8 rounds the 1 up to a 2. One of the other options for finding the binomial probabilities in GeoGebra is to use the cumulative distribution function. And that's just asking us to put either true or false at the end. In this case, we're going to use false because it is not cumulative. So we will type in, again, binomial dist, open parentheses, same thing, 10, comma, 0.5, comma, 3, but instead we're going to type the word false afterwards. And that's going to give us the same exact outcome. So 0.1172. All right, now part B of this example says, what is the probability of tossing a coin 10 times and getting at most 1 tail? Well, at most 1 tail means either 0 or 1. So with GeoGebra, it's nice because we can enter in any list of values we want to here. So we will do that now. Let me delete what we have just to make it nice and clean. So binomial dist, open parentheses. We want 10 trials. The probability of success is 0.5. And again, we can type in, oops, I forgot the comma, comma, 0 and 1. We can find those probabilities that way. I'll take a screenshot and bring that to the other note page. Whoa, what happened there? All right. Or we can use the cumulative distribution for exact values. we will use false. For cumulative values, so like up to and including, we can enter the word true, and that will adds all smaller x values. So if I type this in exactly as I see it here, we'll get the same thing. I'm going to save a little bit of time. Suggest that you pause your video here and try it on your own. The solution should be 0.0107. All right, and then we have another example. It says, according to a Gallup poll, 60% of American adults prefer saving over spending. Let X equal the number of American adults out of a random sample of 50 who prefer saving to spending. Part A says, is this a binomial probability distribution? Why? Well, are they independent? If person A prefers saving over spending, does that affect person B? No, it does not. These are independent. Are there only two outcomes? Well, either a person prefers to save or a person prefers to spend. So there are only two outcomes. Perfect. And are there a fixed number of trials? Well, yeah, we only have 50 people, so therefore, yeah, it's fixed. The value of n is 50. What is a success for this experiment? Well, if a person prefers to save, a person prefers to save, that's a success. The probability of a success is 0.60 because it says 60% of American adults prefer saving. Next, we want to use our calculator to find the following probabilities. The probability that 25 adults in the sample prefer saving over spending. Well, again, n is 50. The probability of success is 0.6. And in this case, we want x to be exactly 25. So we have two different options here. The first option is to, let me delete this. Well, we can type in the binomial distribution. Oops. DIST, open parentheses. We have 50 adults with 60% of them preferring to save, and we want 25 of them saying that they save, and then we could just type in false. Oops, I added an extra S. And we get 0.0405. I'll drop a screenshot. Make it a little bit smaller. And move back over. Whoops. Then we can move it back over. Make it a little bit smaller still. Second way of doing this is binomial dist, open parentheses, 50 again, 50 people in the sample. Probability that they prefer to save is 0.6, but we could just use the curly brackets to type in 25. We get the same thing. You'll see it on the screen. Both calculations give us the same probability, the same outcome. All right, part C now says, CB now says, what is the probability that at most 20? At most 20. Well, at most 20 means 20 or less prefer saving. 20 or less. Well, that would mean that X is all of the values from 0, 1, 2, up to and including 20. That's a lot of numbers to type out. Now, technically, we could use the curly brackets or the set brackets and enter in all the values from 0 to 20 with commas separating them. That could work for us. But the second way we can do this in GeoGebra is to use the word true. If we use the word true, this means that we want to find the cumulative probability. So again, up to and including the maximum value. So for this one is asking if the question, it says if the question asks for up to and including x, as it does, not with a specific language, but that's really what it's asking for. At most 20 is like up to and including 20. We can use the cumulative binomial probability distribution. In GeoGebra, we're going to type binomial dist 50, 0.6, 20, true. And I'll show how to do that. binomial, binomial, dist, open parentheses, oops, I hit it twice. We have 50 people in the sample. The probability that they prefer saving over spending is 0.6. And then we want our maximum value to be 20, but we want this to be a cumulative probability. And we will get the solution here. Now, if you go to this website, in the note packet available through my course, this is a live hyperlink on this video. It is not a live hyperlink, so if you wanted to, you could find it in the course notes, or you could just type in this this web link on your own. There's some more notes in here about when to use and how to use the binomial distribution, but this is all we need to know for our class. The last part of this question says to calculate the mean and standard deviation. The mean is pretty straightforward. Again, the mean just represents the expected value for probability questions. Talking too fast. So we're asking the question, what would be the expected number of people who prefer saving to spending? Well, out of a sample of 50, where 60% of the people prefer saving to spending, we would expect 30 of them to save. We just do 50 times 0.6, enter, to get 30. We can also find the standard deviation using the formula, the square root of n times p times q, in this case 50 times 0.6 times 0.4. Well, if p is equal to 0.6, meaning that 60% of people prefer saving, then q is equal to 1 minus 0.6, meaning that 40% of the people prefer spending. So we can type this into GeoGebra. Square root of 50 times 0.6 times 0.4. We get 2 radical 3. Over on the right side, though, you see this blue equal sign. If we press that button, it will give us the approximation of 3.5. So that's how we can find the standard deviation. All right, last question, last example for this video at least. A fair 6-sided die is rolled 10 times. Each roll is independent because the first outcome or an outcome on one die roll does not affect the second outcome on a second die roll. If we stopped here, this would not be binomial because we have 6 outcomes on a 6-sided die. However, it says you want to find the probability of rolling a 1 exactly 3 times. Since we are looking for a 1, this is what makes it a binomial, because our success is now being defined as rolling a 1. The probability of success, the probability of rolling a 1, is going to be 1 out of 6. Our number of trials here is 10, because we have 10 rolls. P we just defined as 1 over 6, and X is exactly 3. So in Geogebra, we're going to type this in as either binomial dist, open parentheses, 10, comma, 1 divided by 6, comma, curly bracket, 3. Or we could use the binomial dist of 10, comma, 1 divided by 6, comma, 3, comma, false. Either one of those will give us the correct solution. I will do one of them here just so we have the solution. I would suggest that you pause the video and try this on your own to see if you can come up with the solution. 10, comma, 1 divided by 6. Just be careful whenever you use the division symbol in Geogebra, it makes a fraction. We have to use the right arrow to get out of the denominator of the fraction to continue typing. And then, we have to hit the f of x button, the function button, to bring up the curly brackets. And there we go. That is our solution. Thanks for watching.